Okay, time to practice using this definition of continuous or continuity to say whether a graph is or is not continuous. All right, so let's pick this function apart so I can tell this thing here is going to factor. So let's do it. X minus 1, x plus 7. So the x minus 1's cancel, so I get the line x plus 7, and you know the x minus 1 cannot be 0, so that means x cannot be 1. All right, so I'm going to draw y equal x plus 7. There's 7. X cannot be 1, hole there, and I know that that hole is at the y value of 8. So this says when x is 1, the y value is 4 down here. Okay. There we go. All right. So why is this not continuous? I see there's a hole, right? So that's called a removable discontinuity. So what I need to do is talk about how the limit as x goes towards 1 does not equal f of 1. I know that f of 1 is equal to 4, because that's what is defined it. When x is 1, y is 4. And the limit as x goes towards 1 is 8. These are not equal to each other. So this is necessary to show that it is not continuous at x equal 1. All right, so let's look at this one. So here at 2 is where it changes direction. So it's that graph. This is at 1. This is down here at -1. And up here at 3 is the y value of 3. All right, I see that this is a jump discontinuity. It jumps. So I'm going to take the limit as x goes towards 2 from the positive side, and that equals 1. And if I take the limit as x goes towards 2 from the negative side, that's -1. Therefore, the limit as x goes towards 2 of the function does not exist. That makes it discontinuous. All right, so I'm looking at this graph of y equal 2 over x minus 3. I know there's an asymptote here at 3. Here's the graph. And when x is 3, the y value is defined at 0. So if I take the limit as x goes towards 0 from the positive side of the function, I get infinity. That is not finite. So therefore, this function is not continuous at x equals 3. Oh, here I have a piecewise defined function. Can we do it? Can we put all the pieces and together to find out whether it's continuous at x equals 0? So if x's are less than 0, I've got the graph of e to the negative x. Looks like that. If x is 0, then I've got the filled in dot at 2. And then cosine of x looks like that. So I'm looking at what's happening at 0. Is this continuous at 0? It is not, because I see I have a removable discontinuity. So let's talk about how the limit as x goes towards 0, of the k of x, I guess I should be using the right letter, right? K of x does not equal k of 0. So k of 0 is defined as 2, and x equals 0, the y value is 2, but the limit as x goes towards 0 is 1. These are not equal to each other, so this is what says it's not continuous.